Welcome to Shipyard, the fastest way for data teams to launch, monitor, and share their data workflows. In this demo, we're going to cover the highlights of what it looks like to manage a powerful workflow with our data orchestration platform. Let's get started. When you log in, Shipyard shows you all of the projects you have access to. Projects help you organize your work as you see fit. When clicking into a project, we'll see all of the associated vessels and fleets that live there. Vessels are individual scripts that accomplish a very specific task. They can be built with code or with reusable low-code blueprints. Fleets are a combination of multiple vessels working together for a larger goal. They're the equivalent of workflows in what you'll primarily be building. Let's go ahead and edit this financial data fleet. This is the fleet builder. On the left sidebar, you can choose to build a vessel with your code, our low-code blueprints, or a custom org blueprint built by your team. You can then edit it, connect it, and delete it visually. In this example, we start off by running two things in parallel. On one side, we're executing a fivetran sync to update Stripe data and wait for it to finish successfully. On the other side, we're downloading exchange rates from an API and uploading the results to a table in Snowflake. Once both of these sides finish successfully, we run our dbt models. If dbt finishes successfully, we refresh our Tableau data extracts. If dbt errors, we send a Slack message to our data engineering team. And as long as dbt completes, whether it's successful or not, we upload the logs to S3. Fleets are unique because every vessel is automatically containerized and will never run into package or version conflicts with each other. At the same time, the entire fleet shares ephemeral file storage. This means that the data that's downloaded or generated upstream is available to every downstream vessel. Once the fleet finishes running, the data is immediately removed. This vessel is built with Python. You can see here that the code is written directly in the UI. You can also upload the code or use our GitHub sync integration to clone the latest commit from a repository branch or tag. Our script is using the request package to get data from an API and pandas to convert the JSON output to a CSV named exchange_rates.csv. This is important, so remember it for later. When you run code on Shipyard, you have the ability to provide arguments if you're running a CLI, environment variables to securely pass secrets, external packages for the language you choose, and Linux packages that might be required, like Java for JDBC. Additionally, every vessel lets you set notifications to determine who should receive emails if something goes wrong. You can also set guardrails to determine how Shipyard handles retries and cutoffs if the vessel encounters specific errors. Let's switch to our vessel that uploads data to Snowflake. This vessel is built with a low-code library blueprint. We have over 60 of these blueprints designed to help you quickly do very basic actions, like download, upload, and move data between the most common tools in your data stack. These are all open source, so feel free to look under the hood. If we don't have what you need, you can always build your own blueprint with code, but we won't be covering that in this demo. When building with a blueprint, all you need to do is fill out a few inputs. In this case, it's your credentials to connect to Snowflake, the file you want to upload, the table you want to upload to, and the method you want to use for uploading. Notice that we're referencing exchange_rates.csv, which is the name of the file we created in the upstream vessel. We don't need to do anything else for the file to be recognized. If our visual editor isn't your thing, you can always edit the fleet configuration using our YAML editor. This is helpful for making bulk changes or sharing fleet templates with others. Now that we've shown the basics of managing a fleet, let's go ahead and run it. In a few moments, the page will begin to automatically refresh, showing actively running vessels in a Gantt chart. While this runs in the background, let's cover how to automate your fleets. You can set as many hourly, daily, weekly, and monthly schedules as you want on the Triggers tab. This allows you to create flexible schedules for any need. You can also trigger your fleets via webhook. All you need to do is run a post request against the provided URL to start building event-driven workflows. Switching over to the Logs tab, you can gain full visibility into how your fleet has performed in the past. At the top, you'll be able to visually tell the status and duration of previous runs. You can also see which runs are upcoming based on your current schedules. By diving into one of these historical fleet logs, we can see what vessels were a part of that run, what order they ran in, how long they took to run, and other bits of metadata. If you click on any of these vessel logs, you're able to see the output that was generated by the vessel. For this vessel that was running dbt, we can see the environment variables that were set, with passwords being obfuscated, the git commit hash, since this vessel used our GitHub integration, and the logging that was printed from running dbt. We've structured our entire logging system to make it really easy to dig in and troubleshoot your data pipelines without having to grep through massive log files. That's it for this demo. For more examples of specific solutions, watch the other videos on our channel. You can get started building data workflows today with our free developer plan. If you need help, you can always reach out to our team by clicking the Need Help button on the sidebar. This will let you live chat, book a meeting with a data expert, and more. We can't wait to see what solutions you build with Shipyard.